Hi, in this video we're going to be working in Chapter 4, Section 2. So probability and we're going to be talking about events. I'm going to share my screen looking at the notes that are available from Blackboard. Hi. All right. So just want to go over some terms which we were using kind of loosely in the first video, in the first section, but just to make sure we lay down the exact definitions. So, and we're really going to be focusing on classical methods of probability. So these are ones where there's that underlying mathematical understanding of what's going on in the system. And we define an experiment as an action that has n possible outcomes. And if the outcomes are equally likely, then the probability of each outcome is 1 over n. A sample space is a set of all possible outcomes. So in the dice that we were looking at earlier, this here would serve as our sample space. Okay. And then an event is some specified results that may or may not occur, and it's a subset of the sample space. And we saw the event that we had looked at was that the sum of the dice are 4, so that one of these 3 outcomes occurred. Okay, so we let E be an event, and then we're going to use this notation, P open parentheses, E close parentheses, to represent the probability of event E. We say the probability of E. All right. So we want to consider an experiment that consists of rolling one die. I think I'm going to try to go over and go over to the whiteboard. You can see over on the whiteboard, I have the 2 die experiment already laid out on the left. So I'm going to use the right-hand side of the board here. Okay. So I'm going to stop sharing my screen so you can see the whiteboard better. Great. Okay. So we want to consider a different experiment. So we'll consider that next. But here's my experiment that I want to talk about, and that is we roll 1 die. Okay. So what are the possible outcomes? I should tell you it's a 6-sided die. So here are the possible outcomes. If I roll 1 die, 1 through 6, if we state that it's a fair die, then we know that all these outcomes are equally likely. Okay, so I want to just talk about a couple of different events here. So we'll let event 1 be defined as a 3 shows. That is, we roll the die and we get the 3. So then we want to look at the probability of event 1, and that's going to be the number of ways that E can occur, that event 1 can occur. That's otherwise known as F, over the size of the sample space, and that's known as N, right? So we can write that as equal to F over N. Let's go ahead and clean up that a little bit. Good. All right. So in this case, there's only one way that 3 can occur. So the probability of event 1 is 1 over the size of the sample space, which is 6. Okay, that's the probability that if I roll a fair die, it shows a 3. Okay, let's look at the next event, an even number shows. So from the notes, we have event 2. And we are looking at an even number shows. So I'm going to come over here and just underline the way event 2 can occur. So it can occur with a 2, a 4, or a 6. So event 2. is the number of ways the event can occur, which is 3, divided by the size of the sample space, which is 6. So I'm perfectly fine if you want to leave dice probabilities in their natural denominator of 6, or maybe in the case of a 2-die, we'll have a 36. Also, similarly with cards, you don't have to reduce. You might over in my stat lab, but when you're working on homework that's coming into me, we can take the answers in terms of 6, 36, and in terms of cards, it would be a 52, but we'll get to that in a little bit. So let's go ahead and look at one more event from the notes. Event 3 is that a number greater than 4 shows so we roll the die and we get a number greater than 4. We look at our sample space. We are looking for greater than 4, so it doesn't include 4, but it does include the 5 and a 6. And so the probability of that event is going to be 2 out of 6. All right. So taking a moment here, I just want to move my notes forward on my side screen. Okay, so I know where we're going with the dice. Okay, so I want to now talk about a slightly more complicated event, and that's the event that you roll 2 dice. And again, I indicated it with the red and the black, like in the notes. So sort of remember that, you know, there are 2 dice. There really are. And the most important place to think about that again is when you want to consider the 2, 4 red, black is actually a different outcome than the black, red. So a 4, 2 is different than 2, 4. Okay, it doesn't really play the same thing with the doubles, but it does when the numbers on the dice are different. Okay, so the size of the sample space is 36, and we want to look at the probability of getting a 10. Okay, that we roll 2 dice and the sum is equal to 10. So that we're going to look here on our sample space, and we note here that we can get a 10 with a 6 and a 4, a 5 and a 5, or a 4 and a 6. All right, so the probability of getting a 10 is the number of ways you can get a 10, 3 out of the size of the sample space, 36. All right, so moving over to the next problem, we want to look at the probability of getting a double. Okay, and to get a double, there are a number of doubles. Notice that they take this diagonal here, and I'll kind of wiggle them over here. So 1 and a 1, a 2 and a 2, a 3 and a 3, 4 and a 4, a 5 and a 5, and a 6 and a 6. Maybe I should have erased the previous event, so let's go ahead and do that. So we have only the double showing here on the board. Okay, so hopefully that clears up the image of the event a double shows. So what is the probability of getting a double? It's going to be the number of ways a double can occur divided by the size of the sample space, which is 36. So 1, 2, 3, 4, 5, 6. 6 over 36. All right, and how about the probability that the sum is equal to 7? So having the sums constant is comes in this across diagonal in the other direction. So try and get those while I clean up the board. See how many ways you can get a 7. All right. So to get a 7, I can get a 6 and a 1, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, and a 6, a 1 and a 6, or 6 and a 1. So these indicate here that little kind of diagonal, the number of ways to get a 7. So the probability that the sum is equal to 7 is going to be 6 over 36. Okay. So what I want to do next is I want to kind of pick up with this sum, the sum being 10. We worked on the sum being 7. But when we roll a die, what are the possible outcomes for the sum of the two dice? When we roll 2 dice. So when we're in this experiment here, that's on the board, okay? So you roll 2 dice. The smallest number you can get for the sum of the 2 dice is 2. And the largest number you can get is 12. So let's go ahead and think about each of those sums. All right. And I'm not going to mark them all up, but you can on your notes if you like. So the probability of a sum, that the sum is equal to 2, we come on over here and we see that there's just one way to get the sum equal to 2. So the probability of a sum is 1 over 12. The probability of the sum equals 2 is 1 over 12. The probability of the sum equals 3. Come on over here. And you can see there are 2 ways that the sum is equal to 3. So that's 3 over 12. Oh, look, we have a couple already. We have the probability the sum is 10 is 3 over 6. And the probability the sum is 7 is 6 over 36 over 36. Clean it all up. I apologize. This is because you guys are not in the room helping me keep it correct, but I think we're good now. All right, so remembering that the total number of outcomes in this experiment is 36. So all of our denominators will be 36. Okay, I'll try and get better now here. Okay, counting on 4s. 1, 2, 3 ways. Okay, 3 ways to get a 4. 2 ways to get a 3, excuse me. Let's count up 5s. 1, 2, 3, 4. 4 ways to get a 5. So the probability of getting a 5 is 4 out of 36. And the probability of getting a 6, 1, 2, 3, 4, 5. 36 is the probability of getting a 6. And we already calculated this one here. The probability of getting a 7 is 6 out of 36. And just continuing to look at 8s. 1, 2, 3, 4, 5. 5 out of 36. Number of ways to get a 9. 1, 2, 3, 4. So it's just going down now. It's almost like your little diagonal is getting shorter and shorter. How many ways can you get an 11? 2 out of 36. And how many ways can you get a 12? 1 out of 36. All right. So this is all possible sums that you can get when you roll a die, 2 dice, and their associated probabilities. Just a note. If we add these all up, we're going to get 36 out of 36. That is to say, the probability of getting some sum is 1. Any sum, right? Which is what one of the basic ideas in probability. So moving on and coming back to the notes, I'm gonna take a break and I'll meet you in the next video.